I know where there's some, right here in the hall, clerk.
No, Molly, I have
Hello, welcome back. Episode 9 of the Zenith 10H20Z. This time we're looking first of all at the cap. Recall there are four power conditioning capacitors in this chassis. The first set does the radio itself. The second set conditions power for the phonograph. So I restuffed had to wait for smaller diameter capacitors to restuff this one. They finally came in. The procedure for restuffing it is exactly the same as in the other one. And at this point, I'm just checking with my cheapo ESR meter to make sure that they are indeed installed correctly and are working. As I recall, this is a 20 and a 40 in the same can. And yeah, there's 39.7 microfarads out of that one, so the other one should be close to 20 if it would stand up. Push the magic button, see what happens. And it says 20. 20.8. Very good. Here's a shot of it installed back in the chassis. Looks good, I think. This isn't for everybody. I know that a lot of people don't want to take the time to restuff a can, but it's there. I figure I'll use it, and I don't have to make space underneath for a couple of capacitors. Anyway, I'm happy with the way it turned out. Here we are back with the Zenith 10H20Z chassis. As far as I know, I'm done with it, and today's the day we're going to find out whether I'm really done with it or not. I've touched virtually every part of this radio, almost literally every part of this radio. Took out a lot of components, including the audio transformer. That's the new audio transformer from Hammond. It's one of their smaller push-pull transformers that would fit in there. It's an 8-watt. I think this is a 5-watt radio, but as we start to get some power on the 6V6s, we'll be able to tell what wattage it really is. I have replaced every capacitor except the ceramics. I've fused the power supply. I've replaced actually. Well, this had a couple of Y caps in it originally. I put one X cap in it. Added a cap back from, there's power that gets supplied to the phonograph here. And so I added a cap from there to that neutral to chassis ground. What else? I've covered everything else, I think, in the previous videos. I did restuff there's also, because this provides power to the phonograph, it has its own AC filter capacitors, so I replaced those, restuffed those as well. So everything under here has been touched. I did resistance measurements from the PhotoFact schematic. These two tables. This is resistance and this is voltage readings. The resistances all look pretty good. Not perfect, and not every one of them is right. But you know, this is done without the tone stack hooked up or the speaker. So I expected some of them to be off, but the bulk of them are on the money. So I'm feeling pretty good about starting the process of bringing up power. And let me show you what I've got for that. Some folks feel pretty good about just turning radios on. I never have, I never will. I like to ease into it so that it doesn't surprise me and burn the house down and electrocute me. So what do? I plug a hefty isolation transformer. Into that, I plug the variable transformer, the variac, and into that I plug what I call the Tipton box. This is my dim bulb tester based on one that Dave Tipton built at his site. And into that goes the radio. So the process is power on, the isolation transformer, turn that all the way down, power that on. And because the variac is feeding the Tipton box, it won't, and there's a display in here. The display won't actually start working until about 50 volts, but that's fine. The Tipton box has dim bulb in series, dim bulb short-circuited, not in series. It has master power is here. I'll turn that on. And this powers the outlet on the side here that will power the radio. So as I bring the variac up, we're in dim bulb mode, but as I bring the variac up, we should see the display come on. It's around 50 volts. I'll give you a close-up of that. Okay, the way this works, you do master power on, set it to whichever mode you want. Dim bulb is down, full current is up. Apply the variac power, and at around 50 volts it will kick in. There it goes. 57 in this case, and it shows the voltage coming into it. Current passing through it right now, which is nothing because there's nothing plugged into the outlet, which is here. Also does a wattage calculation for you, and then watt hours, frequencies down here in the lower left corner, and a power factor. This box, this display and sensor unit is primarily used for just monitoring power of things to make sure nothing has gone awry. I readapted it for this use. They're really cheap. I burned up the first one, spent another 15 bucks and got another one. So not bad. So how am I going to proceed? Well, as I said or hinted at, I'm a pretty conservative guy when it comes up to applying power, particularly to something that's been touched everywhere as this one has. So the first thing I'll do is, you can see, let me turn it over here. It's tubeless. There are no tubes in there at all. And what I'm going to do is make sure this thing works first, the power transformer. So I will attach my handy dandy meter to a couple of places where I know there should be some AC going in, and a couple more where there should be some AC going out, and we'll make sure that's working. The first place we'll look is right here to make sure we've got power coming through the switch, through the fuse that you don't see on the schematic, but it's in fact in front of the switch. And the way I'll do that is, since the phonomotor socket, the upper and lower pins of that socket are easy to get to, and they go right across the primary of the power transformer, I'll hook up there and then we'll apply power and see what happens. So the variac is set at 0. The Tipton box is on. I'll turn on the output, and at this point now I'm showing 0.23 volts. I'll bring up the variac. Oh, by the way, this sits here, but it's an isolated case, so it's not going to cause any damage. So those 60 volts on the primary. .46 milliamps. Didn't go much higher than that. There's 95, is 100 volts, 80 milliamps. That's just what the power transformer is burning, just sitting there with no load. And 120. So we've got 7 watts being used by the power transformer. And again, keep in mind from prior videos that this is not the original power transformer. This is another Zenith, a different model of Zenith transformer that was substituted in. So anyway, we're at 122 volts. We have power to the primary. The on-off switch works. Over here, we have pilot lights that work. So yay, that's the first test. Now what I'll do is hook up to the output of the, well, we already know, given that the pilot lights are on, we already know that this leg of the secondary, this secondary is fine. This is where the two bulbs are. We'll look here and make sure we've got about 350 volts on each side of the center tap going to the rectifier, and go on from there. Okay, still no rectifier tube in there yet, so we're just looking at the, we'll start with the 5x3 pin 4 and 6 for the plates of that guy. There's pin 4. And that's 380 volts, about right. Pin 6, the other side. This is to chassis ground, which is where the center tap is, and 383 volts, which looks good too. So that's good. Now we'll check the other end of the 5x3, the heater, and that's 2 and 8. Let's see what kind of voltage we're getting there. There's 2. Nothing. And 8 is 5.47 volts. Yeah, so that will need the tube in place to do anything on the other side of that. So that looks okay. Next, I will repopulate with the 5x3, and we'll run through part of this again. So I'll turn the power off on the radio, turn down the Variac, and reset. I'm getting ready to put the 5x3 back in the radio. And I pulled it out of the box and forgot that it had tested bad. So I wanted to test it one more time. This is my little Sencor emission tester. Got it all set up to go in here. And this is a twin diode, keep in mind, so we'll test both sides. That's why it tests bad. Grid leakage looks okay. Shorts. There's a short on H. Normal short on H and HK. Okay. Okay, H and K, or HK down here. So the shorts are all right. This needs to be on D. But the emissions on that diode aren't very good. So let's change it to look at the other one, which is just F. Look at the emissions on the second diode. Not much better. So I bought a couple of replacement tubes. We'll try these guys out. The vendor I bought these from tested them. Let's even get his testing results on it here. So we'll see if we get the same mileage. Oh, that's much better, isn't it? Grid leakage is fine. Shorts. And in the allowed places. So that's very good. We'll switch this back to D. Check emissions on the first diode, and that looks good too. So I think we're in good shape with this tube. Or are we? Emissions are fine. Grid leakage is up there in the questionable area. I've got a short or an open problem in this thing. Let me check the other side again. F and D. Here's F. Ooh. The grid leakage is on the second scale, the lower scale, and it's definitely up into the bad. Well, that's a bummer. Let's try the other one. I think this one is questionable. Let's see what comes out of this box. Over 3. That looks good. That looks good. We'll try the other diode. Emissions are good. Grid leakage is in the good range. So yeah, the other one, the original one, the emissions are way down. The second one we looked at, emissions were fine, but grid leakage is like crazy. And this one looks good. We'll try shorts just for fun. One there, one there. That's as it should be. All right, I think we're good. Found a tube. I'll trash this one. It's always a question, isn't it? This tube is right in here. You could probably use it in an emergency. On the other hand, I've got so much marginal stuff around. It's going in the garbage right now. The other tube I will, this one, the second one I bought, I will, that tested with grid leak, I will test on my other tube tester. Meanwhile, we'll keep this one and I'll put this one in the radio. All right, got the speaker hooked up as part of the power setup. I've got the tone switch front panel hooked up, and I've got the 5Y3, the new 5Y3 that tests good, hooked up. What I'm going to do now is ease up the power and hang the probe right here on pin 2 of the new 5Y3. That should give us 340 volts DC as this comes alive. And then we'll check on the other side of this, what used to be a canned ohm resistor, this 1000 ohm resistor right here, and see that we're getting 280, 260, 60 or 80, can't read it, in that range on pin 4 of the one of the 6V6s and the sockets. The tubes aren't in yet. It's just to check to make sure we're getting B+. So we'll go to ground right there, and then we'll go to, what did I say? Man, good memory, huh? Pin 2 of the 6V6, which is right here. Okay. On dim bulb, Variac power is down, master is on. I'll turn, make sure the radio itself is on. It is. I'll turn the output on, and we'll be watching this voltage right here. I think you can see that as we bring up the Variac. Okay, it's starting to conduct. That's at 50 volts coming into it. Boy, it's all over the map. Um, 59 volts, 130 milliamps. That's a little odd, isn't it? Oh, that's because it should be DC, you dummy. Okay, it's stabilized. Of course it was wobbling around, it was trying to measure AC. So what we've got at 76 volts coming in is 310 out of the 6V6, or 6Y3. So we'll run this up to 100. This radio was built, designed to handle 110 volts input. And keep in mind we're still in dim bulb mode, and the bulb isn't even glowing, so that's a good sign. Okay, with 110 volts input, we have 440 volts on the output of, or the beginning of the long leg of, we have 446 volts right here. It should be 340, but keep in mind it has no load on it at all. So that's good. That means that all of these windings are working, and that the 5Y3 is working as well. So what we'll do is go up here to pin 4 of one of the 6V6s. It doesn't matter since they're hooked together, and see what's going on up there. And pin 4, 1, 2, 3, 4. It's this guy right here. Yeah, and we've got no current flowing through it, so there's no voltage drop across this 1000 ohm resistor either. So 454 volts. So that's a good sign. Now I feel good about repopulating the tube set, putting a load on this. And what I'll do, Well, we'll measure in the same places when I get all the tubes back in. But what I'll do is let it cook for a while without worrying about whether it makes any sound or anything, and get a temperature reading on this power transformer. I just want to make sure this doesn't run hot by nature. So I'll shut it all down, wind that back, turn that off, and turn this off to save some battery. Turn the chassis over and put tubes in. All right, all the tubes are installed. We have the meters sitting on pin 4 of the 6V6s right here, which should show us B plus it. Fully loaded should be 260 volts, it looks like. Yeah, so. And by the way, this is why you should short the filter caps. Filter caps are still, these are brand new filter caps, and they're still carrying 158 volts on them. So if you're going to stick your fingers in there and poke around, make sure you bleed those off a bit beforehand. Not a bit, completely. All right. Same process as before. Variac is all the way down. We're on dim bulb, so if anything goes catastrophically wrong, we should see this bulb light up. We've got power on. We'll turn on output to the radio, turn on the radio, and bring up some voltage here. And remember, this display will light up about 50 volts. Yeah, and our B plus is climbing up. So we've got 75 volts going in right now. Bulb looks good. We've got 386 milliamps. And look here. That's not a good sign. It's pulling 27 watts at 66 volts, which is wrong. That's a bit much. So it feels like there's a wiring error or a couple of pieces of wire crossed over in there somewhere. Or a tube just shorted. Could be any of a dozen things. But it means I've got some work cut out for me now. So, time to get out the ohm meter and start checking paths and making sure everything is as it should be. Okay, I spooked myself unnecessarily there. When you have a dim bulb set up like this, without all this even, just a switch and an outlet, which works just as well, believe me, you pick the wattage of the bulb depending on how much current the radio is going to draw. And I forgot to look that up. So this radio, if you do look it up, this radio draws almost an amp at 115 volts. So when I have this set to dim bulb, and you can watch the voltage drop across the, I'm going to turn the radio on here in a second, but you can watch the voltage is right now at 111 coming from the Variac. And when I turn the radio on, you'll see that voltage drop quite a bit, and this will do what it should do. Well, we'll see. Bright, then dims down as the radio warms up until it's, turn this light out. Virtually invisible, just the softest little glow in there. But you can see also that the radio is drawing 350 milliamps, and the voltage itself is down to 71 and dropping. So as the caps charge and so on, it will draw more and more current, and the bulb will start to come on. Let me shut that light off again. The bulb is starting to come on here, but that makes perfect sense. At a half an amp, you're drawing enough power through this whole circuit. Remember, it's going through this bulb and through that meter and feeding the radio. So you're drawing enough current to light this up a bit. I mean, it's not glowing white hot as it would if there were a short. But there isn't a short. But this is dropping our voltage from 110 about to 63. So what I'll do is I'll take that out of circuit, and we can watch the voltage, the line voltage being fed to the radio, jump back up because the bulb is out to 110, and there's our current up to 800 milliamps, almost an amp, which is where it should be. That means, actually what that means, unlike the All-American 5s in particular, which don't draw much current, this thing is a current hog because it has this, it has a couple of extra tubes because it's AM, FM, and it has this push-pull circuit with two 6v6s it has to push around. So it's a hefty radio in that sense. So there it is, 875 amps, 20 watts of power, or 90 watts of power, and that's all well within what it should be. So let me put the camera back where it belongs, and we'll continue for a bit. So the radio is drawing an appropriate amount of current. What's not happening is any sound coming out of the this monster speaker. And I can't even hear a hum, which is either good news or bad news. So we'll do a couple of things. I've got my signal generator has an analog output. What I'll do is turn the radio off and come over to the speaker. Without doing anything extraordinary, just bridge these contacts. Yeah, I can hear that. I don't know that you can hear that. But let me turn it over again. Yeah. Tip it up this way. Be a touch louder. Yeah, so it's making a slight kilohertz tone. Okay, turn the radio back on. What we'll do is taking that same signal generator, we'll drop, there's a pointer. Taking that same signal generator, here's the push-pull output stage right here. So what we can do is we can connect that same signal to the control grid of each 6v6 in turn, which would be this point and this point, and see if we get tones out. We're stimulating each of these tubes separately, and see if we get tones out through this and any louder to the speaker. Now we don't hook that directly, of course. We use a capacitor. This one happens to be a 0.047 cap. So one side to chassis ground, the other to pin 5 of each of these tubes. And they're right here. There's one here, there's one here. And again, this is really, there's 350 volts floating around in here. So this will knock you on your can if you don't pay attention to where your hands are. And one good idea is always to have one hand in your pocket while you're doing stuff like this. But I'll turn the volume up all the way, although that probably won't make a difference. We're after the volume pot. Let's see. So 1, 2. We'll try this one nearest me first. 1, 2, 3, 4, 5. Oop. Knocked ground off. Yeah, so that's going through the output transformer into the speaker through the tube, so it's being amplified, and then out the output transformer into the speaker. So let's try number 5 on the other tube, which is this guy. There. And that works as well. So that's the good news. The good news is the output stage is working. It's not humming. It's dead quiet. But that also means that nothing is getting in. So where we are is, at this moment in time, so we know we have signal here, but we don't know as if anything is getting in from all the rest of this into this point. So I'm going to have to step backwards. For example, since this is push-pull, the signal comes out of the detector, the audio signal comes out of the detector, goes down in here and gets amplified one more time, and then half of it goes to this 6v6, the other half comes down here, gets inverted, and goes through by the phase inverter and goes through this 6v6. So the phase inverter has to be working, and if it doesn't work, I believe we'd still have half a signal. The 68 here and here has to be working. This is the detector and the first audio frequency amp. So that has to be working. And then we have these 3 stages of IF to deal with, all the way back to the original RF amplifier here. So the first thing I think I'll do is, because it'll tell me quickly, is I will inject our 455, yes, 455. I'll inject our 455 AM signal in here someplace, just before the limiter, before the discriminator, and see if that is carrying the signal appropriately out through the output. So signal in here, out through this way, like that. But I'll do that the next time. So I'll see you later. Take care. Stay safe.